Hello, good afternoon. Welcome again to our next session in our subject in practical research 2. So we're now in lesson 3, kinds of variables and their uses. I'm your teacher, uh, Dr. Christopher Raymond S. Castillo. So let's begin. So what is the meaning of variables? So the root word of the word variable means vary or simply can change. Variables are among the fundamental concepts of research alongside with measurement, validity, reliability, cause and effect, and theory. According to Bernard, he defines a variable as something that can take more than one value, and values can be words or it can be numbers. So by meaning, variables are changing qualities or characteristics of persons, or things like age, gender, intelligence, confidence, and others. All social research is based on defining variables, looking for associations among them, and trying to understand whether one variable causes another. Still, other experts define a variable as any entity that can take on different values. Simply stated, anything that can vary can be considered a variable. An attribute, on the other hand, is a specific value on a variable. For instance, the variable gender has two attributes. It can be male or it can be a female. So variables may differ from gender, age, socioeconomic status, or attitudes or behaviors such as bullying, racial discrimination. So a variable specifically refers to a characteristics or attributes of an individual or an organization that can be measured or observed and that varies among people or organizations being studied. So what are the nature of variables? So variables are classified into four. So we have this what we call the first level type of variable is what we call the nominal variables, which represents categories that cannot be ordered in any particular way. A nominal scale describes a variable with categories that do not have a natural order or ranking. You can code nominal variables with numbers if you want, but the order is arbitrary and any calculation such as computing a mean, median, or standard deviation would be meaningless. So examples for this is what you call the blood type. So we have at least four blood types: the type A, type B, type AB, and type O. So you can assign these blood types to numbers, but they cannot be measured to a computation of the mean, median, and mode or any types of statistical tool. So that is an example of a nominal scale. The second one is what you call the ordinal scale. The order of variables represent categories that can be ordered from greatest to smallest. So an ordinal scale is one where the order matters but not the difference between values. For example, of ordinal variables includes educational level. So we have this what we call freshman, sophomore, grade 11, grade 12. So another one is income brackets. So these are examples of ordinal variables. They cannot also be used in the computation of mean, median, and mode, and any standard deviation or any statistical tool. The third level is what we call the interval variables. So these variables already have values that lie along an evenly dispersed range of numbers. So an interval scale is one where there is order and difference between two values. So it's meaningful. So examples of interval variables includes temperature, okay, in Fahrenheit or in Celsius, the pH reading, or the SAT score of the students. So the credit score, for example, the credit score is from a range of 300 to 850. So examples of interval with data include temperature, net worth as well, and so net worth is computed on how much would be the value if you will subtract the gross income with the deductions or the debt. So the fourth one is the highest level of variable is what we call the ratio variables. So we have values that lie along an evenly dispersed range of numbers where there is an absolute zero. as opposed to net worth, which can have a negative debt to income ratio level variable. So that is, you can have income or some positive amount of income. Most scores stemming from response to survey items and ratio level values because they typically cannot go below zero. So a ratio variable has all the properties of an interval variable and also has a clear definition of zero, where when the variable equals to zero, there is none of that variable. So for example, is the uh, dose amount of a medication, reaction rate or the flow rate, concentration. You can also get the pulse, the number of pulse per minute, and the weight as well, the length, and the temperature in Kelvin. So in the survival time. When working with ratio variables, but not interval variables, the ratio of two measurements has a meaningful interpretation. So let's now go to the kinds of variables. There are two major types of variables or kinds of variables that is commonly used in practical research or in researches. So we have the independent variable and the dependent variable. So the independent variable, these are variables that probably cause, influence, or affect the outcomes of your research. They're invariably called the treatment, manipulated, antecedent, uh, or predictor variables. On the other hand, dependent variables are those that depend on the independent variables. They are the outcomes or results of the influence of the independent variables. So, for example, in a study to determine whether how long a student sleeps affect test scores. So the independent variable here is the length of time spent in sleeping, while the dependent variable is the test scores. And the second one, you wanted to know which brand of fertilizers is best for your plants. So the independent variable is the or the brand of fertilizers, and the dependent variable, which is the health of the plants, which affect the height, the amount and size of flowers and fruit, and also as well as the color, is the dependent variable. Number three, you want to compare brands of paper towels to see which holds most liquid. So the independent variable is the brand of the paper towel, and the dependent variable is the volume of liquid absorbed by the paper towel. So I hope that um, you understood, no, the two types of variable. This is because this is the most commonly used variables in research, particularly in determining or in formulating your titles in research. So another example here is this one. So the independent variable in study is what is the effect of the amount of water to the size of the plants or to the plants itself, particularly the size, the number of leaves, and uh, the viability of the plant. So in here, the amount of water being introduced to the plant is what we call the independent variable. This is also known as the predictor variables or the cost variable. And the size of the plant, the number of leaves, and or the viability of the plant, if it will live or not, is what we call the dependent variable or the effect of the independent variable or the results of the study. We also have different kinds of variables. We have the what we call intervening or mediating variable. So this stands between the independent and the dependent variables, and they show the effect of the independent variable on the dependent variable. The intervening variable is a hypothetical variable used to explain causal links between other variables. This cannot be observed in an experiment. That's why they are called hypothetical. So example of an intervening variable is what we call the lack of access to health care. So for example, if you have a study regarding poverty that that affects the longevity of life of a particular person or an individual. So the lack of access to healthcare is what we call the intervening variable because uh, this is somehow associated between the poor for having a shorter lifespan. The fourth one is what we call the control variables. So this is a special type of independent variables that are measured in study because they potentially influence the dependent variable. Researchers use statistical procedure, like for example the analysis of covariance, to control these variables. They may be demographic or personal variables that need to be controlled so that the true influence of the independent variable on the dependent can be determined. So example of a control variable is this one. So these are all the variables that must not change to make sure it is a fair test. So for example, investigating how a weight affects the length of an elastic bandage. So in order for you to control these variables, you must use the same elastic band all the time and the same scale and etc. So that your uh, collection of data in measuring your data will not be affected. So the experimenter makes a special effort to keep other factors constant so that they will not affect the outcome of your study. So another example of a control variable is this one, investigating how the rate of cooling of a beaker depends on the initial temperature. So you must use the same beaker with the same amount of water as well in the same position in the room and at the same room temperature, so it is a fair test. So these are what we call control variables. So this is another example. For example, if you have a study regarding how does a green light affect the growth rate measured in a mass per time of plants. So the control variables includes both plants are the same species of the same size at the start. They are subjected to the same temperature, the same amount of water and type of soil kept from, and also it must both plants should also be kept from any pest and others. So this is what we call the control variable. In order for the effect, for the affectation of your uh, or the result of your study will be more valid, or it will increase internal validity. The fifth one is what we call the confounding variable. Confounding variables are those that are not actually measured or observed in the study. They exist, but their influence cannot be directly detected in the study. Researchers comment on the influence of compounding variable after the study has been completed, because these variables may have operated to explain the relationship between the independent and the dependent variable, but they were not or could not be easily assessed. So a compounding variable is an unmeasured third variable that influences both supposed cause and the supposed effect. So it's important to consider potential compounding variables and account for them in your research design to ensure your results are valid. So for example, your confounding variable, you need to collect data on sunburns and ice cream consumption. You find that the higher ice cream consumption is associated with a higher probability of sunburn. Does that mean that the ice cream consumption causes sunburn? Of course not. No, definitely it's not. So here, the confounding variable is the temperature. So hot temperatures cause people to both eat more ice cream and spend more time outdoors under the sun, resulting in more sunburns. To ensure the internal validity of your research, you must account for compounding variables. If you fail to do so, your results may not reflect the actual relationship between the variables that you're interested in. For instance, you may find a cause and effect relationship that does not actually exist because the effect you measure is measured by the confounding variable and not by your independent variable. So these are examples of your variables actually. Said Patrick Vigoniel in 2012 advances this example of variables. So phenomenon A, for example, the climate change. So example of variables related to climate change would be the sea level, so temperature, the amount of carbon emission, and the amount of rainfall. So most definitely, the independent variables might be the the amount of carbon emission and the increase of temperature on the Earth's atmosphere, particularly the biosphere, would affect the temperature, no? The increase of temperature because of the um, accumulation of too much carbon in the air. Same as with the sea level, no? Which is a dependent variable, and the amount of rainfall also is the dependent variable. Another phenomenon in our example for variables is the crime and violence on streets. So the number of robberies that you can also include the variable, number of attempted murders, number of prisoners, number of crime victims, number of law enforcers, number of convictions, and number of carnapping incidents. So that depends on how you will approach your study. No? Independent variables might be the number of law enforcers. No? Because if there is a lack of law enforcers, most definitely this will affect the number of violence or crime in our society. So the dependent variable might be the number of robberies counted, and the number of attempted murders, or the number of prisoners as well, no? And number of convictions might also be an independent, or it can be a dependent variable, and the number of carnapping incidents is a dependent variable. In the phenomenon C, the study is poor performance of students in college entrance examination. So examples of variables related to poor academic performance is the entrance exam score, the number of hours devoted to studying, student-teacher ratio, number of students in the class, educational attainment, teaching style, the distance of school from home, and the number of hours devoted by parents in providing tutorial support. So you can find many different independent variables that depends on how you will approach your study. It can be the student-teacher ratio, which affect the poor performance of students in the college entrance examination, that which is the dependent variable. Also, the education attainment of the teacher may also be an independent variable that affects the poor performance of the student, particularly in taking the examination and the college entrance test. The teaching style as well is the independent variable that affects the performance of the students. Okay, so those are the examples of the variables in this study. So what are these traits of variables? So most traits, variables should have to be exhaustive. So this should be includes all possible unsuitable responses. That's why if you will be making your research, you need to exhaust all of your variables in your study. You need to include all the different variables that can affect the results of your study. The second one is mutually exclusive. So no respondent should be able to have two attributes simultaneously. So meaning that these variables should have to be associated or related with each other, and it should always be mutually exclusive with one another. So that ends our lecture. So thank you very much, and I'll see you again for our next session in Practical Research 2. So we will be going next time in Chapter 2, Lesson 1. Thank you very much, and good day.